Good day, everyone. My name is Rebecca Lilly for the International Association for Energy Economics. It gives me great pleasure to welcome you to today's webinar entitled Peaceful Uses of Nuclear Energy in Less Industrialized Countries, Challenges, Opportunities, and Acceptance. First, a little bit about the International Association for Energy Economics. We are the largest association specializing in the field of energy economics and provide a forum for the exchange of ideas, experience, and issues among professionals interested in the field. The organization produces 2 professional journals, a newsletter, and holds conferences and virtual presentations, along with a host of other products and services that you can find on our website at www.iaee.org. If you're not already a member of the association, we welcome you to join. A few housekeeping matters in regard to today's webinar before I hand things over to our moderator. First, this webinar is being recorded for those that cannot participate in today's live event. If you have questions for the panelists, please click the Q&A button at the bottom of the Zoom window and type your question. We've allocated sufficient time at the end of the webinar to address your questions. And now I would like to introduce our moderator, Ricardo Raineri, past IAEE president and professor of the engineering school at Pontificia Universidad Católica de Chile. Ricardo, over to you. And Ricardo,
thank you, Rebecca. Welcome everybody to this webinar where we will be talking about peaceful uses of nuclear energy in less industrialized countries, an issue that sometimes is a little bit forgotten in our webinars. So I am happy that we have this opportunity here from the International Association to host this webinar with I think 3 outstanding energy experts with a deep experience in the nuclear energy sector. Nuclear energy is an important part of our energy matrix. It represents about 10% of the electricity that we produce, and also plays a key role in other sectors of our economy, providing services in agriculture, health sector, and other areas. It's also nuclear energy, an issue that can work very well to help the society in solving today's energy challenges. Particularly, for example, it's recognized as a low CO2 emission energy sources to combat climate change, but also can play a key role today that energy security is a challenge after the Russian invasion of Ukraine, where European countries are facing important challenges in terms of how they can supply their energy. So we have 3 outstanding speakers, Jeffrey Binder, Antonio Muller, Ted Jones. Jeff Binder has over 30 years of experience in applied energy technology, both in engineering and also as a scientific contribution. He has had in the past leadership roles in the Oak Ridge and Argonne National Labs, and Jeff has played a key role in the United States in supporting and solving nuclear safety and security issues following the 3 Mile Island accident, the dissolution of Soviet Union, and the following Chernobyl accident, and also in the Fukushima accident in Japan. Jeff has a PhD in nuclear energy from the University of Urbana, Illinois. Then we have Antonio Muller with over 40 years of experience with executive positions in Brazil and other places. He is an expert has been deeply involved in the implementation of nuclear power plants in the design, engineering, construction, and commissioning in Brazil. He has over, we can say, 2,500 megawatts of accumulated experience in nuclear power plants. He has been president of several nuclear associations, such as the Latin American section of American Nuclear Association, the Brazilian Nuclear Association, and also has been in the World Association and World Nuclear University. He has a bachelor in mechanical engineering from Universidad de Rio de Janeiro, and also extension in USA, Georgia Tech Institute, Drexel University, and Harvard University. And then we will have Ted Jones, who is Senior Director for National Security and International Programs at the Nuclear Energy Institute. Is an expert in international energy markets and nuclear trade policy. Mr. John leads initiatives related to nuclear energy export, including nuclear cooperation agreement, nuclear export control, finance, export promotion, and related issues with nuclear energy. Mr. John has a bachelor degree from Brigham Southern College. Also graduate from history at the University of Georgia, and also has studies at law at Georgetown University Law Center. So thank you for being here. Welcome. And we will start with a presentation by Jeff Binder that will look at the safety issues and challenges. Then we will go with Antonio Muller, that will talk about the Brazilian experience on nuclear energy and where they are planning to go. And then we will have Ted Jones that will talk about more of the economic policy issues related with nuclear energy. So Jeff, the floor is yours. Thank you very much.
Well, thank you very much, Ricardo. And I'm going to share a few slides here. If I can pull them up correctly. Here we go. I'm very excited to talk about the opportunities that are coming for nuclear energy across our world. As many people understand and know, to get to zero carbon, we cannot do this without nuclear energy as well. But we need to keep all the energy systems available to us moving forward, in my opinion. We're in a very good point here, I think, to start engaging globally on advanced energy technology. And I'm going to talk a little bit about the major questions that have come up in the announcement of this webinar, and the things, and then I will complete with talking a bit about the safety issues. So starting off here, I wanted to talk first about how can IAEA and other industrialized countries support capacity building in less industrialized countries to be ready for a yes or no decision regarding peaceful uses of atomic energy. And I have done some background. I've had experiences with the IAEA in my career. I've done a lot of international things over my 30 years, as Ricardo said. And the IAEA has a major document that if people want to reach out to me and talk to me about is milestones in the development of a national infrastructure for nuclear power. And there are actually 19 infrastructure issues, and I'm not going to go through all the details now, but safety, security, investment, all those things have to come together. And engaging on all those activities, I think, are going to be really key, and working that internationally is going to be very important. So that's one thing there. And I will tell you that the U.S. State Department is now also reaching out, it's working closely with the IAEA, but also reaching out for the United States to engage more internationally to support advanced reactor technology. And there was a major bid that came out of the State Department to put webinars and meetings and discussions together. And I think the U.S. is going to be really engaging to work closely with many countries across the world for industrialized opportunities. So this is very exciting. Now, I will say on the human capital and scientists and experts, doing the training and the education support in that is going to be really key. And I think the U.S. is going to be important, but other countries are going to be very important for this as well too. And I think that there's a growing interest, I will tell you, in companies in the U.S. to engage internationally as well, not only for the advanced reactor technology, but also for training and developing human capital and pulling the experts together as well too. So that's one big thing I think on moving forward for countries across the world. Then the next thing is the nuclear power, a realistic and cost-effective solution for less industrialized countries, given significant upfront investment costs and construction periods, and our SMRs turn on a key solution for less industrialized countries. And I'm a very big supporter of this, and I'm going to show you here. Whoops, there we go. I'm going to show you here one major concept for a micro SMR reactor. These are 1 to 20 megawatts of thermal energy for both heat or electricity. They'll be small and portable, factory fabricated, so they're not all fabricated on site, but they're going to be factory fabricated and actually moved there by a truck or moving things in other ways. It'll be very simple designs and self-adjusting, and our 50, 60 years of knowledge and history of advanced reactor systems and advanced materials and advanced fuels is really coming important, I think. And it's, and I think for many countries, these smaller reactors are going to be really important for fitting the grid, but also for things like supporting the mining sector, for example, or producing green hydrogen, which is going to be a key part, I think, for transportation moving forward. Because I don't believe that lithium batteries is going to be the complete solution for that. So quick on-site installation, it's transportable. Electricity is very clean and reliable. And for non-electric, we're going to look at water desalination as well. That's another thing I should have mentioned, is water desalination being very important. And then hydrogen fuel production, as I said, as well, too. And the picture I'm here is from Nano Nuclear Energy, which is a startup microreactor company out of the US. It's very engaging internationally as well, too. And I wanted to mention those as well, too. So I'm very excited about the advanced reactors that are coming. And I will tell you the other thing on the refueling of those reactors, they will only happen once every 10 years. Okay, so we don't have to refuel once or twice a year like we do for much larger reactors. Okay, so so moving on to the next thing is critical characteristics of technology when deciding on different alternatives of nuclear technologies available in the market and future SMRs, but also other nuclear technology. And I wanted to, another thing that I was very involved with in my career was the development of isotope production, particularly for medical applications. And here we can see a case of actinium, which was used for treating cancer, and how it can be very supportive. And there's a growing role of development and advancement of technologies to domestically produce radioisotopes here in the US, but also internationally as well, too. And developing domestic production has been driven by non-proliferation goals, aging traditional production facilities, and the increase in opportunities for application of radioisotopes for science, medical, and industrial demand. So this is something that's also very exciting to see as well, too, in terms of nuclear technology, is the application of isotope development for many applications, but for people treating people's cancer is going to be really key as well, too. Okay, and then and I'm going to finish with my major background and my technical background, which is in the safety side. Okay, so as Ricardo mentioned, Chernobyl, 3 Mile Island, and Fukushima were all accidents that I had some involvement in my career with. When I started my career with 3 Mile Island, I was an experimentalist on solving some of the last major technical issues from the accident of 3 Mile Island. But and then after the Soviet Union collapsed, and it was after the Chernobyl accident as well, too, I became the US lead for engaging on safety and security somewhat, too, across all of the various countries where Soviet design reactors were. And I can show many pictures of my many places that I've been throughout my life, through a war there were all these various Soviet design reactors. And then later in my career, when Fukushima happened, I led the U.S. support analysis out of the Department of Energy for several months. to help Japan with the Fukushima accident. So now there were fundamental technical issues that I won't go into details now from all of those reactors, and that go back in the history, that we've learned quite a bit about moving forward and have improved. And certainly moving forward with small modular reactors and microreactors, many of those safety issues that existed in those reactors are not going to exist anymore in these advanced reactors that are coming. But I also want to talk about, here it says, how can we assure the safety standards in a broad sense have been enhanced to preclude future situations like this one? So part of it is the technical and the science side of it, but should the safety standards must depend on organization structure. And I can tell you there was a lot learned about organizational structure from all of those accidents. If you go back to the history with 3 Mile Island, for certain reasons, not all the information was at the facility and the operation side of those reactors, and that has changed dramatically in the United States. We share broad information across all our reactors and share all that information now so that we can understand where issues could be coming or not coming and all those things as well too. And I will tell you, in the Soviet Union, Moscow wanted to control all the information about the reactors, and that was particularly true at Chernobyl. Is the operators in Ukraine had no real information on issues that could be coming for the accident there, and so now I can't say where things are going in Russia now, but I think that was a major thing, is to share that information. And I went to all of these reactor sites in the former Soviet Union and opened the doors up for them to get more information about basic understanding of the technology and the security of the facilities as well too. And now Fukushima, a little bit different now within Japan, because this was a generation 2 reactor from the design from the 1960s. It was but obviously there was an earthquake and a tsunami that was made this a very incredible issue and locked out the energy that was needed to keep the reactor going, because the emergency energy, electricity for that, and of course, because there was an earthquake and a tsunami, there was a very unbelievable thing that happened in that I think we learned a lot about, and we've learned a lot about how to better design things for those kinds of things as well too. So all of those issues are really good, but I think engaging the communities across this globally is going to be very important moving forward for reactor safety moving forward. And so I want to make one last point here. So I support a number of different companies over the last couple of years, but Boston Government Services is a company that's really supports clients in both the United States and across the world now, and looking to go across that, and it has many experienced scientists, engineers, and technical professionals who can support these activities. And I think these companies are going to be growing as we move forward, because there was a lot of people that didn't come into the nuclear system, particularly in the United States in the 1990s and early 2000s. And so we have to, take that background experience and bring that in, but also develop and train and get not just scientists moving forward, but also operations people, safety people, and the security people for all of the nuclear activities. And BGS is one company that's a great example of supporting that for both the private sector side and also for the national labs within the U.S. system. And BGS does a lot of support for the Idaho National Lab, which is where a lot of the demonstration activities of advanced reactors are going to be happening over the next 5 to 10 years in our country. So with that, I'm going to go ahead and hand it off back to you, Ricardo. And I appreciate everybody's time and look forward to engaging on more things going forward. Thank you.
Thank you very much, for your presentation. Just a comment to our audience. You are invited, please, to make questions in the chat. So at the end of all the presentations, we will pass all the questions to our speakers. So feel free to put your question in the chat. Antonio.
Yes.
You have some echo, so eventually you should mute one of the microphones.
Yeah, can you hear me clear?
We hear you, but with echo.
Okay. And now,
I can mute one of his. Let me give it a
Okay.
try.
Thank you, Rebecca.
All right, can you try again, Antonio? Oh, now they're both muted. Let's undo one of them.
No, we don't hear you, Antonio. You are mute.
hello?
Okay, we can hear you now, but there is a bit of echo. So
Yeah.
maybe if you try speaking softly, that may help.
Hello? Yeah, has an echo, no?
Yeah.
And now,
Still has echo.
okay. I'm going to disconnect the computer. I'm going to go to. Hello? Still. Oh boy. And now, it's okay?
Yes, that's better.
Can you put my presentation, please?
Oh,
I have it here. I will
Yeah.
share the screen.
thank you.
Give me a second.
Very good. Thank you, Ricardo.
Perfect. You can start, Antonio.
Okay. That's not moving. Okay, let's see.
I think you'd like the
Okay.
next slide.
Okay, let's do the following. The presentation is available, and I'm going to present what is in the detail in the presentation. Really, several countries in Latin America are using nuclear power plant in several segments like energy, industry, medicine, hydrology, environment, food, and agriculture. In Brazil, in South America has three countries that have a nuclear power plants. One is Mexico, the other one is Argentina, and the other one is Brazil. In this presentation, I'm going to focus in Brazil, what we are doing here, the way that we are developing nuclear power plant here in Brazil, and show our experience in Brazil. Can you show the next one? Yes. Building capacity. We started, when we decided to go nuclear, we started in 1968. Brazil decided to go nuclear. And that time, the Brazilian Commission of Nuclear Energy gave authorization to start, and Furnas, that time was an electric utility, very important electric utility in Brazil, that went to nuclear power plant. Then, after long studies with support of American companies like Nuclear Utility Service, Tabasco Service Corporation, very old companies that some still on, some disappear. We prepare all the bids and so on, and we select Westinghouse. Luckily, we select pressurized water reactor because we had a lot of types of reactors at that time. The problem there is that the local content was very, very small, less than 20%. And really the local engineering was known for non-nuclear area. But it started, a long investment was done to train people in all the phases, security, safety, quality assurance, nuclear power plant, and so on. And the local construction erection was done by local companies with foreign supports. Can you show the next one, please? Then in 1975, in that period, we were discussing in the United States to have 2 more nuclear power plants of 950 megawatts. That time I discussed with I was living in the United States for this project, and I was negotiating with 2 companies, but I received a message from Brazilian minister to stop any negotiation because Brazil going to do the agreement with Germany. So in that time was done an agreement for 8 units, 1,300 megawatts. One of the key points was transfer of technology. This was key. So with this, we started under 2 and 3, both 1,300 megawatts electrical. So the Brazilian content was increased heavily, engineering in Brazil, using private companies and electronuclear. What's electronuclear? It's a company belongs to the government that in the beginning was an agreement between KVU and Nuclear, which is a local Brazilian company. Then the German people left Nuclear and was created Electronuclear. It's a government-owned company that does engineering and management, project management and construction and operate. They're really the operation outfit of a nuclear power plant in Brazil. Implementation of quality program. With the case of the German, we have the support of QV. In case of Angra 1, NRC was the support. And with this was created some companies. One of the companies that was created was heavy manufacturing equipment. Today, this company is called Nuclep. It's still working very, very heavily in the industry. So they manufacture the steam generator, reactor vessels, pressurizer, heat exchanger for nuclear power plant, and in parallel, Brazil has one program, which is with the submarines, nuclear submarines, agreement with France. So they are manufacturing equipment also for the submarine and also the cask of submarine. And with this, Brazil, create another company. It's called INP. INP is the manufacturer of fuel, nuclear fuel. So together with the passing agreement with Germany and so on, this company was created. It's totally Brazilian today. So we manufacture fuel for Angra 1, partial loads, because we don't have a full capability to produce all the load that we need for Angra 1, 2, and 3. But in Angra 1 is almost 100%. Next, please. The unit 1-1, the question of institutional framework. I think this was important because we learned hardly, but I think today's we had a tremendous institutional framework. Nuclear power plant. CNEN, which is the Comissão Nacional de Energia Nuclear, was the main authority. And CNEN made agreements with the NRC, the Nuclear Required Commission of US, to help them to establish all the framework, establish the requirements, and so on. And this, so Angra 1 was based on a lot of support of NRC from the United States. Next one, Angra 2 and 3 is a combination of Brazilian, US, and German requirement. Based on that, was created a company called IBQN. I am in the board of IBQN. It's Instituto Brasileiro de Qualidade Nuclear. It's a host. So they help the client to see if everything is going on, everything is going correct, and so on. And also, IBQN has the authorized authority in Brazil, in agreement with the American Society of Mechanical Engineers, to do the N stamps for the equipment manufactured in Brazil. And also they had agreement with TÜV Nord. This is an outfit of Germany. In meantime, in 1991, it's very interesting, this was created ABEC. It's a Brazilian Argentina Agency for Accounting and Control. So really, with this agreement, this association look the question of account of fuel in Brazil and in Argentina also. So it's a very, very important, it's a very successful organization. Right? And in the meantime, a lot important investment was done in training manpower for engineering, for construction, and for operation, for sure. This is a key. And also with the important participation of all Brazilian universities, especially Rio de Janeiro and São Paulo. Both of them has a course of nuclear power, nuclear energy in both universities. Next, please. But Brazil, as you know, the Angra 1 had a lot of delays and so on. Now it's going on. Companies was contracted for construction of the nuclear area. Brazil, they're already in sight, erecting the steel containment in the area of nuclear and emergency buildings. And they are selecting engineering to finalize the engineering. The engineering is almost 67% done. Kinen, then with this, Kinen, which is the regulatory commission, was split in two because many years, especially the agency in Vienna, was pressing Brazil to split this because we had a conflict. Sometimes they are safety responsibility, they had a safety responsibility for the plants, also the promotion of the plants. So they split it. So we have Kinen now responsible for promotion, nuclear energy laboratories and development, and the Autoridade Nacional de Segurança Nuclear, responsible for standard safety, radiological protection, and safety of nuclear installation. And for sure, we have a very important support from IAEA and industrial countries like US, like Germany. Next, please. But Brazil decides really to implement the other power plants. So they decide to have up to 2050 around more 8 plants, around 10,000 gigawatts plant up to 2050. Today, the participation of a nuclear power plant is very small, it's around 2%. Hydro is still the big one, but wind and solar are going up and biomass also is going up. Please, another one. With this, as I had mentioned, we have a plan to 2050 to decarbonize the country using a nuclear power plant, as I mentioned, that we're going to have 10,000 gigawatts new electric power plants in Brazil. Maybe one are going to be in the site of Angra. Site of Angra is a very tight site, but it's very important because they have all the infrastructure, have 2 villages for the people that are working there and living there and so on. And we have a lot of strong support of the community because Electronuclear invests too much in community, giving hospital, invest in the city and so on. So the support there from the community is very big. Next, please. So what we are is not defined yet the places of the installation. As I mentioned, we are looking Angra 4. We have a space for 1 more unit. And in the northeast of the country, we are looking for possible 6,600 megawatts in Pernambuco state with an investment of $30 billion US. The technology is not select. Today, with Angra 3, we are using the French because the French, they bought Kraftwerk Union, they bought Siemens and so on. So we are looking as a technology Framatome, Westinghouse, Rosatom. Rosatom was very aggressive in Brazil to sell the VDR. However, I don't know what is going to happen now. We need to, as Jeff mentioned, we need to see the development, what's going to happen. The Chinese also, with the cap 1400, is very active. And for sure, we are looking detail to invest, to participate, and implement SMR here in Brazil, we are talking with all suppliers, and we are looking to these plants because, as I mentioned, that can be from 1 megawatts up to 75, 77, 300 megawatts if you have more units and so on, like a new scale are doing. So really, we are focused too much in SMR. Financing, we have two types of financing, by the plant supplier and by the bank in Brazil, developed bank in Brazil. And they are deeply involved in the question of Angra 3. So the country, the Brazilian government are putting too much money in the companies belong to Brazil to invest in nuclear power plant, and also the bank is deeply involved in the investment in these plants. Next, please. Final remarks. Brazilian government and industry decide to focus heavily on decarbonization. Excuse me. Focus in nuclear power plant, wind power plant, solar power plant, and biomass. Brazil has a very interesting developing biomass. And to have, for sure, nuclear power plant for base load to support all the other technologies. Thank you very much for your attention, and please feel free to use this presentation, and feel free to make any questions that you want. Thank you very much. Thank you, Ricardo.
Thank you, Antonio, for your presentation. Ted?
Good morning. I'll share my slides. Is this visible to everybody?
It is.
Perfect.
Okay, great. Thank you, Ricardo, for inviting me, and it's a pleasure to be on a panel with Jeff and Antonio, and to speak with you today about nuclear energy in less developed countries. I'll begin with just a few notes about the U.S. and what's driving the resurgence of nuclear energy here, and then say a few words about what's going to press it in overseas markets in the years to come, and what kinds of advantages the world can derive from it. I think most of you know that nuclear energy provides a significant amount of the electricity in the United States. It's consistently been about a fifth of the power generated here. Even as some plants have shut down, we've implemented uprates at many plants, and added the equivalent of many new reactors just in additional power capacity. And so we've stayed steady at about a fifth of electricity generated, but that's over half of the zero emitting power generated in the United States. So it is really critical for the U.S. To meet its climate goals. Worldwide, the energy security. Sorry, I'm got to stop the auto advance here. I'll just use this slide, if everybody can see it, so it won't automatically advance. Energy security was a critical driver for nuclear energy even before the Russian invasion of Ukraine. Nuclear helps promote energy independence. It's less susceptible to spikes in fuel prices because uranium is just a small fraction of the cost of power relative to what fossil fuels are for natural gas or coal-fired power. And generally, fuel is procured under long-term contracts, so the actual cost borne by utilities that operate nuclear plants is much more stable. A year ago, Europe was experiencing, and the world to a lesser degree, a crisis in energy prices, and this was really mitigated in Europe by the nuclear generation there. I spoke recently to some executives at the Bulgarian national utility, and even before the Russian invasion of Ukraine, their nuclear power plants were subsidizing all the generation on the grid and enabling the nation to weather a surge in energy prices that would have bankrupted their industry and made their residential customers suffer a great deal. Since the invasion, nuclear power has become even more valuable in the eyes of energy planners in Europe and around the world. Obviously, climate change is also a very big driver. We saw at COP26 last year, nuclear really take its place in the arsenal of nations uniting to address climate change, and that is going to continue. It's not just the governments that appreciate it, but it's also private industry. It's industrial customers of electricity generators is looking for clean energy solutions, and some of these users are looking directly at nuclear to power some of their own operations directly, as I'll discuss a little bit more. But in the United States, it's the utilities that are really making our electricity policy. We don't have national planning the way some countries do, but what you see here is a map of the utilities that have made commitments to reduce their carbon emissions, and they've made these commitments to their regulatory bodies, to their shareholders, and to their customers, and they intend to keep these commitments. They really don't have any choice, and they're turning their attention now to how they're going to achieve these commitments. Many people assume that nuclear energy has a higher marginal cost than wind, so it will never be the solution to climate change. But it's not the marginal cost of electricity that is the relevant criterion here, or at least not the only relevant criterion. Because if you go with renewables only, you have to overbuild renewables so massively, and also deploy massive utility scale battery storage to have power available when the wind's not blowing and the sun's not shining. And I think it's a huge myth that that has thrived not just across public opinion, but even into a lot of policymaking communities that this is this underestimation of the cost of an overbuild in a renewable only scenario. But study after study, including the studies the utilities have done themselves, but also studies produced by experts, have shown that if you add nuclear to a mix of renewables, that you can significantly reduce the overall cost of a clean energy system. MIT, conducted one of the studies I'm referring to here. They estimated that if you add what they call firm low carbon power generation to fuel saving, which is renewables, since they aren't really using a fuel, and fast burst, which is what you have with electric battery storage, you can save on your decarbonized electricity system costs between 10 and 62%. So, many people just, are still learning this. And I noticed, especially in outside the United States, that this assumption that nuclear is the expensive option, it continues to thrive. But I think as countries, especially we've seen this in Europe in the last 18 months, they have really, a lot of them have really turned around in their thinking as they've appreciated this. Another widespread myth is that has it's diminishing now, and to the benefit of nuclear, is an underestimation of the total amount of electricity that we're going to need to decarbonize our economies. We need electricity not just to replace the fossil generation, but we need to have more electricity and more clean energy to power our economies in transportation, manufacturing, and other areas. Most immediately in Europe, I had seen, as countries in Central and Eastern Europe, which have been most forward-leaning in developing new nuclear, they're trying to retire a lot of coal plants, and if these coal plants are providing district heating, and if they like right away are going to have to replace not just electricity, but a huge amount of energy to keep their communities warm in the winter. But as Jeff mentioned, it's a lot of things. It's water desalination. It's process heat for industry. I know a lot of countries are looking to hydrogen to power their economies, not just in transportation, but in industry, including Brazil. How are you going to get the hydrogen? I mean, right now it's mostly coming out of oil and gas refineries, and you end up with the same problem if you're putting it all on renewables to generate that hydrogen. So all of these factors are combining to create real commercial opportunities for new nuclear in the United States and overseas, and not just in wealthy countries. Here you see a selection of small and advanced reactor projects these are firmly planned projects that are, many of them, as you see, coming online, scheduled to come online this decade. Few people understand how far along these projects really are, but you see these projects have utilities to buy the power. They have sites, and many of them are well along, and there's many others right behind these that I think you'll see announced in the months to come. And I wanted to say one other word, that I think is especially relevant for developing countries. We should, I think, take some note of the events of this past year in Ukraine as a reminder that nuclear energy partnership is a long-term proposition. It's based on mutual trust and respect, and carries really important ramifications for national security. It's not easy to replace the OEM in nuclear energy, and so you should make the choice wisely. It's you should choose a supplier that doesn't use nuclear energy, and its role as that supplier to leverage its own foreign policy interest, or just to achieve mercantile goals and tilting the balance of trade in its favor, building it all and then walking away. And you shouldn't. You should look for a country that has a proven record as an industrial partner, because there's a tremendous job opportunity in nuclear. And it's not just, I'll take the example of Brazil, since we have Ricardo and Antonio, and actually we're going to be hosting in Washington a delegation from Brazil this month. So it is on my mind. Brazil, if it builds the nuclear that Antonio outlined, it will create many jobs. But if Brazil partners in the development of some of these next generation technologies, which are more like building airplanes than airports, it could be exporting these plants to the world and helping the world create a clean energy system. And it's a huge opportunity. I mean, Brazil's got a lot of expertise in engineering, construction, manufacturing. Look at what Brazil's done in aviation. This could really be, it should be seen as that type of strategic economic opportunity for world export and long-term partnership between the US and Brazil, because I do think that we have got some good examples of industrial partnership and tech transfer, localization, that we can extend in this new area and help not just our own countries, but the world address the challenges of climate change and energy security. So with that, I think there's, some important lessons that nuclear energy has for achieving our energy security benefits, our decarbonization goals, and just developing robust economies that can help us and our future generations thrive in the world to come. So that concludes my presentation, Ricardo.
Thank you very much, Ted. I want to invite our speakers if they have a comment. Jeff, Antonio, you want to comment, complement each other's presentations?
If I can make a comment, Ricardo, I'm very pleased to participate in this webinar because the presentation of Jeff and Ted was fantastic one, showing that some fields, Jeff showed some fields that Brazil is investing too much in health and so on. And the presentation of Ted matched too much with mine because he's focusing development of countries and so on. And that's what we invest on in Brazil, to develop nuclear power plants in the less developed country like Brazil. Brazil is underdeveloped country for sure. And one thing which is important, I forgot to mention, that Argentina also is investing, especially to the Chinese people, and they are developing a small reactor of 50 megawatts in Argentina, which is very, very important. And for sure, Chile, I think, start to talk also to implement nuclear power plant. I think so, Ricardo. This is what I'm hearing. And again, for me, it was a big pleasure to participate in the webinar with you, Ricardo, Jeff, and Ted. Thank you very much.
Thank you, Antonio. Jeff?
Well, thank you, Ricardo and Antonio. It's I think the opportunities that the United States is starting to realize to support the international community is becoming growing, and hopefully we can support that. But even in the United States, we have to improve our training and education and get people ready. I will tell you that, and I think, we're going to work that. I see Ted shaking his head yes on that. But as I've worked with Ricardo for a number of years now, and we very much see the same things for where we have to go for our energy system moving forward. And I say it all the time to many people, and Ted, I totally agree with you. We're never going to get there just with solar and wind. It's just not going to happen. And we gotta, like we always say, does the sun always shine and the wind always blow? And also, how does the grid going to function just on that energy system? It goes up and down when the wind stops blowing or the sun stops shining. And and that's where the nuclear can really provide and then we've learned so much over the last 50, 60 years, as I said, and I'm just really excited to engage internationally on supporting these activities going forward. And as I mentioned, I'll say one more thing, Ricardo, as I mentioned, I'm supporting some of these startup companies, and Ted mentioned a few of them there, but there's some other ones coming as well too. And I think there's some real opportunities coming for small modular reactors or micro reactors. But in some places, you don't need just small, as you said, Antonio, sometimes you need a larger reactor too, but I'm really excited to support all these things. So thank you, everybody.
Thank you, Jeff. Ted, any comment? We have a question from Javier Cuervo also that I want to pass to you.
No, I'm just glad that I could go last to hear the presentations and respond to them. It is an exciting time internationally, and what's really exciting to me is to see, with the advent of the small and advanced reactors, the global map for nuclear energy start to expand. Countries that never would have dreamed to build a large plant because of its size or cost relative to their needs or grid size are finding, or in just the fact that it's all electricity generally for most large plants, are seeing in these smaller plants a really a good solution for their needs. And I think it just echoing what Jeff and Antonio said about human capital development is going to be a real challenge for us all. I mean, just to achieve the projects that are on the board to come online this decade is a big challenge, because we haven't been doing it. And I think that once those projects come online, the whole world is going to want them. There's so many countries that are very interested in nuclear power. They don't want to be first. They all want to be second. So we're seeing something kind of like a hockey stick projection of nuclear, kind of staying at the level we're in right now, which still is, as we mentioned, quite a challenge, and then taking off once those projects come online, which we really need to be getting ready for today.
I'm sorry, can I make one more comment, Ricardo? Yeah.
For
So,
sure.
yeah. So I really like what you say as well too, Ted. And you know, I sometimes often remind people about the technology readiness level, the TRL, that was created by NASA in the 1960s when we got to space, you know, and moving the technology forward. So the first 3 steps in that are typically doing more fundamental science and research. And then the last steps, you know, the 7, 8, 9 steps, you know, they're just, you got it all ready. You're just ready to make it to the market. You just got to build it and put it on the market. The big challenge I will tell everybody is we got to figure out how to get in the middle step from doing the science and the research to the market opportunity and connecting that piece. And I'm really excited that the Idaho National Lab, which is the nuclear lab for the United States, is starting to really realize that. And the lab director has made some public comments about that as well too. And I can tell you the whole leadership team of that team is very close colleagues of mine, and I know them very well. And I think, you know, we're going to see major demonstrations of advanced reactors coming now at the Idaho National Lab, and then it's going to have international benefit as well. That's my view. So thank you.
Thank you very much, Jeff. I don't want to forget Javier Cuervo question. He mentioned that in Latin America, Brazil, Argentina, Mexico have nuclear energy. So he asked if this is a viable option for other countries such as Colombia, Peru, or Chile with no experience. I think we have talked about this during the webinar, but if you want to make any remark on that.
Okay, I think nuclear is feasible for sure several countries in Latin America. How to start? We are talking now about SMRs. I think could be a solution for countries that want to start to have a know-how and nuclear power plants, power generation. Because what happened with SMRs, normally the unit is smaller than the big one. So you can develop a Foxtrot train, start with a small one and go to big one if required. The second point also is that you can manufacture installation or vacation installation outside of the country. So really, you can use this plant to prepare all the site and so on, all the needs of the infrastructure and so on, and bring and do hook up in the plant like you are doing today in the offshore platform. You bring a lot of modules and you do hook up in the offshore platform. You can do the same thing with small and medium-sized reactor. I think, correct me if I'm wrong, Ricardo, I think one country that is thinking to go nuclear in power generation is Chile. I hear that. I'm not sure it's a firm decision, but the other countries like Peru and so on can go ahead with nuclear power plant. Go small, but prepare the basic structure for nuclear training, licensing. I think that needs a lot of study and investment in our country when go to nuclear. The question of licensing and safety of the plant, and for sure, training, have training personnel. This was done in Brazil when it started under one. The first focus was train people in engineering, construction, safety, quality assurance, licensing, and so on. So I think the opportunity exists. The size of plants exists now that can fit any requirement of any country. So I think they can, if they decide go ahead, but prepare to go ahead, prepare infrastructure and people.
Thank you very much, Antonio. Jeff, Antonio, Ted, any final word?
Again, thank you very much for the opportunity. And please feel free anytime. I can be ready to participate, and you can make my presentation available to everybody. Thank you very much, Ricardo. Nice to meet you, Jeff and Ted. For me, it was a pleasure to participate with this webinar with Ricardo, Jeff and Ted, and Rebecca. Thank you very much for the support. Thank you very much.
Thank you, Antonio.
And likewise, It's been a pleasure to speak with you, Antonio and Jeff. I hope we can continue this conversation separately. And Ricardo, thank you for organizing and for including NEI.
Thank you, Ted.
And thank you again. Yes, Ted and Antonio, I look forward to working and connecting with you some more. And Ricardo, thank you for putting this together. I think it was a very good discussion, and it's a good step point, but a lot more to do. And I'm excited to get going. Very good. Thank you.
No, I want to thank you, all of you, also the IAA, to have the opportunity to organize this webinar on an issue that is coming hot today with the challenges of national energy security, and also I think the opportunities that advanced technology can bring to the countries that prepare to work on these issues, certainly always taking into account social acceptance and security first. So thank you for sharing your thoughts, your knowledge, your experience. I think it's very valuable. The International Association really appreciate your participation in this webinar that is very important for us. And thank you very much. And Rebecca, back to you.
IAEE wishes to thank Ricardo Raineri and all of our distinguished panelists for an outstanding webinar. This webinar will be available on IAEE's website for future downloads. If you're not a member of IAEE, we encourage you to join by visiting www.iaee.org. We thank you for attending, and I officially close this webinar.